Looking for fascinating conversations with industry thought leaders? Want to get the inside scoop from local legends? Interested in the stories behind the stories from celebrated visionaries? This is your home for the best our university has to offer. Welcome to We Are IU.
Hello everyone, I'm Brittany Slissa-King, your host, and today we are diving into the fast lane, and I mean that quite literally. You guys see how I did that? Okay. They're smiling, so here we go. Today we're exploring the world of autonomous vehicles with artificial intelligence, and recently a professor and a group of Luddy students came together and brought IU innovation to the Indy 500 track, and now they're officially known as IU Luddy's Autonomous Racing Team. Trust me, we're going to unpack all of that, break it all down. But first, let's meet our guests. So gentlemen, welcome to the podcast.
Yeah, hello everyone. I am Lantao, and I am an associate professor in the Luddy School of Informatics, Computing and Engineering. I do research and I teach on robotics. I am the team principal, so I oversee and lead the entire team.
Hello everyone, my name is Durgakant Pushp. I am a fifth year PhD student. So my research is about decision making. I'm trying to model robots like human. For the racing team, I'm the team lead, and I'm also trying to oversee all the process and how we try to achieve our goal.
Hi. My name is Hassan Jardali. I'm a third-year PhD student at Luddy. I'm mainly focused on the planning and control module for the car. So I do research and I implement algorithms to assist the car in finding the best race line or trajectory, and then converting these waypoints to control actions like throttle, brake, and steering.
All right, guys, let's get into it. Artificial intelligence in racing. Naturally, my first question is why? But my other question is, why AI for each of you? What is your backgrounds in AI? And then also, did you guys grow up as like race car fanatics, like loving Tony Stewart or something? Like, because I'm so interested in how two of these marries.
I think I started working in robotics maybe 12 years back during my undergrad. I was trying to build some small planes and try to develop algorithm to land it autonomously.
Yeah. For me, I grew up liking cars as every boy. So I was a kid.
Hassan's the fanatic, obviously.
Yeah, he probably the one that's really true.
Yeah, so I was that kid that will get a small RC car, disassembled, get the servo cars, and then reassemble it for like with another design. I studied mechatronics during my undergrad, and I always wanted something that combines like hardware and software. And the best thing was like studying mechatronics and robotics, which is a combination between software and hardware. I like cars, I like robotics. What's better to have autonomous racing and have a full-scale car to control it?
I love that. And to that point, Hassan, like, I was interested in how this project came to be, like AI and race car driving. Like, what was the objective of this project from the start? And how did you guys meet? And how did this group form?
We started working on the autonomous racing from, I would say, officially from last year. And so this is also one like a consensus between our lab and also the university leaders. And we want to start this initiative to push the AI in the real world.
Over 150 students wanted to be a part of the team, but only 28 were invited to be included, including you two here. Can you talk more about the working dynamic and how you placed everyone in the right roles for success?
So the working dynamics is purely based on the needs. So for example, in order to make the car running, so we do need people to focus on different domains, like the perception. We have to get one person to lead that field. Mm-hmm. And similarly, we need a person working on the entire system architecture, and we have that person too. And then we have the control guy, the system person, and also the team lead.
We also try to maintain some kind of structure in the team. Yeah. For example, it is not just 6 months project which will get over. So we had to maintain every time, like there is a team that will be doing the developments, that will be aiming towards the next goal. There is a team that is about to leave, and then they are just graduating, and others who are just coming in. So we have to maintain this kind of structure. We have to keep educating the new ones, and then the one who is leaving the team has to also do the knowledge transfer in at the right time.
Also, there is like two types of tasks that are uh, in the team. So, for example, we have like from the coding perspective, we have some code that will be implemented directly on the car, and it will be running online in real time when the car is driving at 100, 120, 150 miles per hour. And we have another type of coding, which is it will be only used offline.
So let's talk about building the car. What did it take one to conceptualize this idea of this race car to building the race car and then having the race car at the Indy Speedway? Like all those steps, can you break that down for us?
Our project was first discussed back in the fall of 2023. So our dean first talked to us, and our dean has a really ambitious goal that we want to use a very short time to catch up with all other long-term playing teams. So in May 2024, last summer, we officially became a team among the 10 global racing teams. So we have only 10 teams global.
So car is being prepared by Indy Autonomous Challenge, the hardware, because the actual Indy Dallara IL-15 chassis, which has been used in Indy 500, one of the races. I think it's Indy Light series. So they remove the driver's seat and then they put a computer inside, and they then put the different camera sensors. We don't have a side mirror to look at because they replaced it and put 6 cameras on top of the car. But cameras are not sufficient for the AI which we want to achieve. So they also put LiDARs. There are 3 LiDARs that can cover almost 270 degrees and more around the car. And the remaining part is being covered by radars.
So basically, it's a software competition. It's not a hardware competition. So we don't build the cars. We get the cars equivalently as all the other teams. And the team that will win is the team that will have the best code, not the best hardware.
Got it. So what you were saying with removing the human out of the car and like putting the computer essentially in the front car, that is something that when I watched some of the YouTube videos of the car on the racetrack, I'm like, this is so cool, but it was like just so strange seeing like a car essentially look like it's driving itself. Since you don't have an actual person behind the wheel, what's the difference in the decision-making of a human driving versus AI behind the wheel?
So our goal is to achieve the human level intelligence without human.
So when we drive, we just see through our eyes, and we can only see to the line of sight, and we don't know what is happening beyond. Let's say there is a left turn. Then we have all our knowledge, that the intelligence which we talk about, our cognitive abilities to anticipate that at this turn, usually at this time, there is no much traffic. And if I don't see anyone, I can just go and merge to the highway, something like that. But for the race cars, they have more information. They actually know where exactly they are on the racetrack, and up to a centimeter of accuracy. Like if we say that there is a start-finish line, anytime race car knows where it is on the track in X, Y, or Z position. And it can also plan ahead. It can just, because it knows the track, and the only thing it should care about is there any other race car on the track or not. And there, like the limitations are same. And at that part, I think the AI sensors are not as advanced as our human eyes with all the developed cognition. So we have sensors which can see, let's say, 200 meters ahead. But we cannot process, the AI softwares cannot process it the same way human does. Like we see a car and we identify that this is a race car. And we also somehow know the behavior of the opponent if there is a human driver driving. So these things are the big challenge for AI. So there is some advantage and also some limitations which we are trying to solve.
And to the limitations, was there anything, like any challenges that you didn't foresee that you had to face?
Every day is challenging for us. Every day. It's like, because there is a big difference. Like we all know that AI is catching up and helping us in many ways, but still there is a big difference between what human drivers can achieve and what AI driver can do. And our project and this project is mostly about how can we push the limitations.
So, for example, if a human is driving the car, the human can feel, or the racer can feel that he's losing a grip, or there is like more grip on that turn, or no. However, one of the challenges that we are facing, like, how can we model or how can we tell the car, okay, now you are losing a grip? That's where we should go back to the mathematics of racing and to the physics of racing and try to implement these equations into our code.
Before we get into the race day that you had at the Indy Autonomous Challenge event in January, we have to talk about the infamous crash that happened in September that I heard almost jeopardized everything. That I read that it could have taken you out of the running to race. So can you bring us to that moment and how are you feeling and what caused that crash to happen?
The IMS.
Yeah, it was on 4th September 2024.
Right. And that one, so no one, everyone
He knows
was
exactly the day
right
and time now.
Yeah.
because that's a big event for us.
Yeah.
Good thing for us is that this is the only crash we had so far. So I think this is the best record among all the global teams. So other teams, they have more crashes.
Yeah.
So as when the car crashed, it runs at I think more than 110 miles per hour. And then so suddenly we lost. It's a car lost control. We lost communication, and then the car started the safety feature, tried to push the brake, and then hit the wall, the tire wall on the racetrack.
So we were kind of unlucky because, so on the IMS track, there are like sidewalls and then they put some tires. So there were tires, like 2 different lines of tire, and there is a small gap and nothing was there. We were so unlucky that we precisely managed to hit the wall. We did not hit the tires.
If we are crashing, it means we are trying to push our limits, and that's our goal at the end of the day. Not to crash, but to push our limits.
I remember we came in this room after the crash because it's like after every run, we have around more than 1 terabyte of data. And we have to look at those data and try to figure out exactly what has caused the crash. And we spent maybe up to 1 a.m. here in this room. And because we have to find out the reason, and the next day, it was very hard for us to debug what has happened because our software looks fine. There was no bug in the software, but there is hardware that has something. There was a port in the computer, and that suddenly started throwing some error. Like it was trying to read something, and then it was some glitch was there. And then I think the race day we removed all the redundant part of the computer just to make sure that we don't want the crash during the final race.
Yeah.
Exactly.
Yeah, this definitely give us a lot of pressure. I still recall that day.
Yeah,
I think
Lantao
everyone
was
has a very
also there.
fresh memory on that, right? So
It's
yeah,
like anywhere in the room, you're like,
it's also very scary because after 2 days we have to go on the track again and the final race, and then something happened to us in an unexpected way. Then we have to figure out what's wrong so we can fix that. But the code is huge, so there are many thousand lines, so many kind of possible places that we have to track down and see where is wrong.
do you think in hindsight, the crash actually helped you set up to be more prepared and ready for race day?
Definitely. So I agree that every failure, it can help us to learn more and also help us to grow, to be mature. So every members, they pay more attention on their module to do full examination on their mod, like their code, their tasks we assign them. So in this way, then it helps us to make our software more robust, like more reliable.
Yeah, I remember when we started working on this project, we actually planned for it. We thought that, okay, we know that crashes are going to happen, but our goal is not to get a crash because of some stupid bug in the code. And we are glad that even like that crash, we learned a lot because we feel bad if we figure out that, oh, I could have just changed this line of code and it was so easy. It's just because of a lot of work and we miss it. So I think we always try not to crash because of some,
Definitely.
some small mistake.
So all your hard work, you're on this race day, all your hard work is riding on this. How are you feeling in like the last hour that they're about to say like ready, set, go? Like what's going on? What are you talking about amongst the team? How are you feeling in that moment?
Our first race, it was 2 days after the crash that we just talked about. It was our first one. We were pretty conservative, especially because we had that incident 2 days ago. And we pushed the car. We made it. We reached a very good speed for our first competition. And we came back. We got the data. We did our analysis. We improved our code. And then we went to Las Vegas Motor Speedway, which is also an oval. It has more banking, which makes things easier a little bit because it will give us more grip to the car. We did few practice days, and then we hit 163 miles per hour. That was our max speed.
So even so, what I can tell is that so our first time trial competition results like a 128 miles per hour. I think his record for the first year team, for all the teams. So it means that we are the fastest for the first year team so far, and also our time for preparation is also the shortest because we have only slightly more than 1 month to touch the real car, work on the real car. And all other teams that participated in in Indianapolis Motor Speedway, that competition, all other teams, they have been running on tracks for more than 3 years, I believe.
Yeah, I read like 4 years since.
Yeah. Most of the teams, they participated back in like 2020 or 2021. So they have longer history than us.
And I even read like a lot of your people that you're competing against was giving you guys praise and feedback, like positive feedback. What were they saying to you?
To be honest, we learned a lot from our opponents because last summer, we were the newest and also the last team added to the entire organization. So I think we are the 9th or 10th, right? The team.
Yeah.
And other teams, they have more experience than us. So sometimes, like for the basic routine thing, we have to ask them, and then whether they can help us to understand this or that. And in general, I believe that all other teams they were super willing to help, like to tell us what based on their experience.
I think ISC, so Indy Autonomous Challenge, that organization in general. So there is a competition for sure, but we try to understand how can we also help others to grow. So they helped us, and at the same time our progress was also maybe more than what they were expecting. So I think even when we first time hit over 100 miles in Kentucky, everyone just clapped for us because I can feel like they also felt happy that a new team just in a month and they're able to run above 100 miles is a big milestone, because when you go above 100 miles, there is so many things that you have to do right.
What's one thing that worked and what's one thing that didn't work?
Well, one thing that's special to our team is that so our resources relatively is limited. So in this way, then everyone needs to be super strategic. And this is, I think, the best thing that I found in our team at HIU, that everyone is so mature, they know what's going on, and they know how to help other guys, and also what's the best way that as a team, we can further push the progress in the most, most efficient way.
I think managing the big team for a long time and keeping them motivated, especially when you work hard, as Lantao mentioned, we have very limited track time. So let's say 3 people worked on one module, like let's say gear shift strategy. But we know that we cannot test all the 3 algorithms on the track because of the limited track time. So we have to discuss among ourselves and say that, okay, everyone's work is great, they put their effort, but at the same time, given the situation and the objective of our next goal, we might go with one person.
I would mention one of the challenges is so each track has its own challenges. There is a huge difference in racing strategy between oval tracks and road course tracks. So in ovals, we don't have very variant velocity profiles. So the speed will be almost constant, let's say at 150 or 160 or 170 miles per hour. However, for the road courses tracks, we need to accelerate, we need to deaccelerate, and that's a huge challenge in road course tracks. And that's actually what we are currently focusing on.
So, Durga Khan, you said that if something works in a race car, it's close to being transferred to society. And then Hassan, you expressed that if we can control our race car at high speeds, the same principles can be applied to normal roads, enabling safer and faster navigation amongst people. And I love what insight that you shared here. Can you elaborate more on this and how this research can possibly eventually bring more safety to everyday drivers like myself?
For example, if you think about 100 years back, the automobile industry improved a lot from the engine's perspective, from the hardware perspective. This is the time it has to improve from the AI perspectives as well. If you face a situation where you do not know what to do, you panic. AI can take over, and that's why we are trying to deal with 160 or 180 miles per hour, because during that small time window, these algorithms can actually help people to prevent some crashes.
Yes, Rebecca. So we all know that one main reason of casualties is like crashes and accidents. And one main reason for accidents in cars is like decision making and communication between two drivers. And now let's imagine if the communication is happening between two AI drivers or two computers. The probability of having miscommunication or having mistakes is way less. And that's I think how I see the future and our research and autonomous racing. We are trying to work on a society where self cars are driving. And why that is because we want to have a safer environment and more efficient by having high speed.
AI is not our goal, especially like what we are trying to do. It's not to challenge human drivers and try to show that in future we can just be better than human driver. That is not the goal. The goal here is to challenge the problems which human driver faces and then be there for assistance.
In general, as Durkan mentioned, that when we work on the autonomous driving or racing, but the goal is not to replace human or create any kind of threat to human, like a workforce, etc. But it's more like we are trying to provide more efficiency to human life.
I love that you guys clarify that AI is not to challenge humans, but to help us. So that's good for the listeners to know. So as we wrap up, we can't conclude the episode without talking about our best friend, IU, and how supportive it's been with this amazing endeavor for you guys. So how does it feel to have such a supportive teammate like IU? And what does that support look like for you guys to make this dream really happen for you?
So IU has definitely, absolutely helped us a lot. So the car was purchased by Luddy School, and the Dean, Joanna Molinchik, has spent a lot of effort in securing the funds to purchase this car. So IU spent more than $500,000 to buy the chassis, which is owned fully by IU. So I want to also use this opportunity to thank all the the people who spend effort helping us in whatever ways. And without you, then we cannot move that fast.
And also for students, I think they are trying to work in a good way. They are trying to learn, and then they are trying to help other than their work. So from the students to faculty members and staffs, I think I felt really good during the entire 1.5 years process.
And we are always, like we always have races. We are always busy. We are always preparing. And we always need people.
Right.
So everyone is welcome to join.
People recognize us as being Hoosiers, and then wherever we go, at IMS, one staff he's working for IMS, and he came to us before the race day and gave us the Trident logo. He 3D printed last night and say that, so I support IU and then I am from IU. It felt really good Like we have some supporters even at
California,
in
yeah.
California, everywhere. Like we find somebody who always come to us and support and recognize us as who's is.
Awesome. Well, my last question is for everybody. How has this huge feat shaped your life now? Because I'm sure like doing something like this is giving you confidence in other areas of your life. So how has this helped you with ambitions and dreams?
I have just one word to say, like one sentence, that I have become more responsible.
For me, I never expected that having overnights in this lab and working on my computer may lead me to tracks and racetracks and actually driving $500,000 Indy car with my code. So on the personal level, it made my PhD exciting.
If I want to use one word to describe that, I'm proud. I'm proud of the team. I mean, I'm proud of the opportunity to work with so many talented students. And then they are responsible. Now they know, appreciate things, and they know about their value. They consider about the society thing. And we learn so much, so many things. I believe that now we are working on the frontier of technology on the self-driving cars. And we will see the great impact very shortly, probably before your graduation or right upon the time you graduate. And then you are trying to, land in some jobs and then do some real things on different types of real cars.
So thank you guys for joining the podcast today and sharing your experiences and knowledge and all the cool innovation that you're doing at the Luddy School. Like, it's really awesome to hear, and I appreciate your time.
Thanks for joining us for another episode of We Are IU, your home for fascinating conversations with thought leaders, legends, and visionaries from the university we know and love. New episodes available monthly at myiu.org.